Okay, now we're going to do section or topic 1.5. This is going to teach you how to look at shapes and describe what's going to happen to the area of that shape if you change some things about the width and length and sides and heights and bases. It's not just going to be rectangles, but you're going to learn how to look at what's happening with each change and how to do that. Find the area. Okay, we're starting with one that is a special right triangle. It's a 30, 60, 90 right triangle, and we're going to have to figure out this length right here, because the width we can get, if this is a 30 and that's a 60 and this is across from the 30, this is your smallest side. This one right here is always twice your smallest side, and this one's always your small side times the square root of 3. That's the 30, 60, 90 triangle. So if twice the small side is 8, that means our side across from our 30-degree angle has to be a 4. And if 4 is our short leg, then our long leg is 4 times the square root of 3. So there we have our length and our width. Our width is 4, our length is 4 times the square root of 3. An area for rectangles is just length times width, so you're just multiplying the 4 times square root of 3 times 4. That's just 16 times the square root of 3. So there's your answer for the area, square centimeters, of this rectangle. Okay, let's go ahead and fill in this chart. What would happen if we change one or both dimensions in this rectangle? I'm going to show you how to do this using, we're going to make a conjecture in a minute, but I'm going to show you how you're going to do this using the original and then the factors of change. Let's go ahead and write our original, because we're going to use the same rectangle 4 different times. Okay, if we use twice the length, well, twice the length means you're going to take the length 4 times the square root of 3, and you're going to multiply it times 2. So 4 times the square root of 3 times 2 would make that 8 times the square root of 3. If you do, oh, I'm sorry, this says width up here. The width is twice as long. I apologize. So the width, I'm sorry, this goes for this one. The width was 4, so twice of that would be 8. Twice as long for the length makes the length, now we're going to do it, 4 times the square root of 3 doubled, so that's 8 times the square root of 3. So your length times width here would be 8 times 8 times the square root of 3, that's 16 times the square root of 3. Oh, I'm sorry, 64. 64 times the square root of 3. Alright, this new divided by original is just you're going to start to notice, we're going to use something in a minute, but you're going to start to notice what's happening. Your new is 64 times the square root of 3. The original is 16 times the square root of 3. If you divide 64 times the square root of 3 by 16 times the square root of 3, the square root of 3's divide out, so it's 64 divided by 16, which is 4. And I'll show you what's happening in a minute. But okay, let's try another one. If you do twice as long, that means you're going to multiply by 2, so that length is going to be, the width is going to still be an 8. But if you make 3 times the length, you're multiplying 3 times 4 times the square root of 3. So that's 12 times the square root of 3. So if you multiply 12 times the square root of 3 times 8, you're going to get 96 times the square root of 3. If you divide 96 times the square root of 3 by 16 times the square root of 3, you're going to get 6. Alright, let's try the next one. 4 times as long for the width, that means you're going to multiply 4 times 4, that'll make it 16 for your width. And then half as long for, you're going to take a half and multiply by 4 times the square root of 3. That would be 2 times the square root of 3. So your length times your width would be 2 times the square root of 3 times 16. That's going to be 32 times the square root of 3. And 32 times the square root of 3 divided by the original 16 times the square root of 3. Again, the 3's cancel out. 32 divided by 16 is 2. I'll tell you why we're doing this in a second. Let's keep going. 1/4 is long. That means the width is 4, and if we do a fourth of 4, that's going to be 1/4 times 4 is just 1. Twice as long. Remember, when you do twice the length, taking 4 times the square root of 3 and doubling it gives you 8 times the square root of 3. Well, the area is length times width. So if you multiply 8 times the square root of 3 times 1, you just get 8 times the square root of 3. So 8 times the square root of 3, the new, divided by the original. This time the 3's cancel out. Now 8/16 reduces to a half. So I want you to look at these numbers over here. And I'm going to teach you, we're going to talk about this next question. It says, what conjecture can you make regarding the changing of dimensions in two-dimensional figures? Okay, look at the numbers that we got when we divided or found how much bigger it got. It got 4 times bigger when we doubled both things. It got 6 times bigger when we made the width 2 times its size and the length 3 times its size. When it got 2 times bigger when we took 4 times the length and half times the width, or the other way around. Anyway, I want you to notice twice means 2, 2. Well, if you multiply 2 times 2, you're going to get 4. Twice 3, 2 times 3, that means it's 6 times bigger. 4 times a half, if you multiply half of 4, you get 2. So hopefully you're noticing what's happening. 1/4 times 2, if you multiply a fourth times 2, that's going to give you a half. So what you need to write here, our conjecture, to obtain, let me read what we're going to write. To obtain the new area, you multiply the original area by the product of the factors by which you are changing the dimensions. Let's take a minute to write that. To obtain the new area, multiply the original area by the product. Product means the answer to a multiplication problem of the factors. Those are the things you're multiplying, by which you are changing the dimensions. Okay, let's use this on our next example so you'll understand a little better. What we're talking about is when things change, you change dimensions on your shape, it's going to change the area. And then the way you know how it's going to change is by multiplying the two two things that you're doing to change it. The product of those factors. Okay, let's try one. Okay, they want to, first of all, what we really need to do is look at this picture and figure out the area of the original. So let's write original area. So our original area, we're going to have to use the area of a triangle formula. It's 1/2 base times height. We have neither one. We don't have the base or the height. So because of the markings here, this word isosceles and the markings means that these legs are both 12s. Because we have a 60-degree angle down here and a 90-degree, we can conclude that this is a 30-degree angle. So we have a special right triangle. And remember that on a special 30, 60, 90 triangle, the short leg, the one opposite the 30-degree angle, is always half the length of the hypotenuse. So this side length here would be 6 meters. And that's not really going to help us with the base, but it is going to help us get the height. On a 30, 60, 90, if you know your short leg, you multiply that short leg times the square root of 3 to get the height. So now we have our height. Actually, we have our base and our height. The base is 12. The height is 6 times the square root of 3. Let's leave these like we've been doing in radical form. So half of 12 is 6. 6 times 6 is 36. So 36 times the square root of 3 is the original area of the triangle. Now look what they want to do. They want to take the base and double it, and the height and triple it. So I'm going to write this as a product of the changes. And what that means is you take the change, what you're doing, you're doubling, which means 2. You're tripling the height, which means 3. Product means multiply those two numbers. So that means the area changes by 6 times. That means it's 6 times bigger. So the new one, I'll just write new area, is going to be your old area times the product of your changes. So you're going to take that and multiply it by 6. Let's leave it in radical form. So you're just going to multiply 6 times 36, which is 216. Leave the square root of 3 as a radical. So 216 times the square root of 3 square meters. So basically what you're doing is you're taking these words, the words doubled and the words tripled, and multiplying them. So you'll know what you're multiplying. See, this right here came from those two words, that word triple and this word double. That's where the 6 came from. So that's how you figure out what you're going to multiply your original area. Let's try the rhombus, number 5. Okay, on this rhombus, just so you remember, the area of a rhombus is when you do 1/2 diagonal 1 times diagonal 2. Now these diagonals are not complete because they're giving you the length from the vertex point here to the center, and that's 5. So the entire diagonal would be a 10. Again, this diagonal, half of it's 4, so the entire diagonal would be an 8. So when you do the formula, make sure you look at your picture correctly and double it if they've only given you parts. So on this one, the area formula is going to be 1/2 40. I'm sorry, 1/2 80, so that's 40. And this is the original. That's the original area. Now look at what it's telling us. Find the area of the rhombus below. If one diagonal was halved, I'm going to circle that word, and the other diagonal was doubled. Remember that the product of changes is going to be those two multiplied. So the word halved means the number half, doubled means 2. 1/2 times 2 is 1. Now when you have a factor of 1, that means there's going to be no change to your area. Because if you multiplied the original area times 1, there's no change. So no change in the area when your product of changes turns out to be a 1. That 1 means there's no change. So 40, 2 little marks, I don't know if you know, means inches. If it's 1 little mark, it means feet. So this means the area would be 40 square inches. Okay, example 6. I was going to draw a triangle, but I don't think we're going to need to. We can do this one without a picture. Let me show you why. Let's read the problem. The area of a triangle is 36 square millimeters. Suppose the height was 3 times as long. Let's circle that one. And the base was 4 times as long. What would be the area of the new triangle? So they've already given us the original area. We multiply it by the product of changes. Let's write that out. The product of changes is going to be the height change, which is 3, and the base change, which is 4. And 3 times 4 is 12, so that means the area is 12 times the size that it was. This is the number you're going to use to multiply by. So if you multiply your original area was 36. If you multiply it by the product of changes, I think I'll write you a little formula here. Original area times the product of change, what you're changing your dimensions, that will be your new area. So we're going to multiply 36 times 12. You can use a calculator. 36 times 12 is 432. So the answer, 432 square millimeters. Make sure you put your unit with an exponent 2 because area is always in square units. Now it's time to do some work. Do it on your own. If you have any questions, come see me.